Hello everyone, this lesson is about wastewater and wastewater treatment and energy from wastewater. Water is essential in our daily life. We all use water for brushing teeth, drinking, cooking, cleaning, swimming, washing, etc. Roughly estimated, a human being needs to replenish the 2 liters of water they lose every day from sweating, breathing, and urination. Water after use becomes wastewater. According to U.S. Environmental Protection Agency, domestic households produce an average of 100 to 200 liters of wastewater per person every day. Water is the source of life, the essential of production, and the foundation of ecology. However, it has also become a resource in crisis around the world, including China. China is a country with severe drought and water shortage problems. The total freshwater resources in China is 2.0 billion trillion cubic meters, accounting for 6% of the global water resources, ranking the 4th in the world, after Brazil, Russia, and Canada. However, the per capita water resources are only 1/4 of the world's average level, which makes China one of the countries with the poorest per capita water resources around the world. In 2002 alone, our freshwater consumption reached 549.7 billion cubic meters, accounting for about 13% of the world's annual consumption. China now is facing a serious water crisis. Lakes and rivers are exposed to diverse pollutants. Wastewater treatment plant effluent is also one of the pollution sources. The problems in current wastewater treatment plants include 1. Unbalanced carbon, nitrogen, and phosphorus, which is essential for the biological reactions. For example, when treating wastewater from pig farms, nitrogen concentration is usually higher than other wastewater. 2. Effluent, nitrogen, and phosphorus couldn't meet the regulation requirements. Current technology couldn't solve the problems mentioned above economically, and therefore, developments of new technologies are needed with low cost and high efficiency through comprehensive utilization and integrated systems management. Let's come back to the definition of wastewater. Water after use, which is contaminated with human, agricultural, or industrial wastes, while typically seen as a nuisance. The organic matter contained in wastewater from our sewage systems can become a valuable resource through biological reactions, namely anaerobic digestion. Anaerobic digestion is a process through which bacteria break down organic matter, such as animal manure, wastewater biosolids, and food waste. In the absence of oxygen, biogas is generated during anaerobic digestion, which mostly contains methane and carbon dioxide, with very small amounts of water vapor and other gases. Biogas is a renewable energy source that can be used in a variety of ways. Communities and businesses across the country use biogas to power engines, produce mechanical power, heat, and or electricity, including combined heat and power systems, to fuel boilers and furnaces, heating digesters, and other spaces, to run alternative fuel vehicles, and to supply homes and businesses through their natural gas pipelines. The 4 key stages of anaerobic digestion involve hydrolysis, acidogenesis, acetogenesis, and methanogenesis. In most cases, biomass in wastewater is made up of large organic compounds. For the bacteria in anaerobic digesters to tap the energy potential of the material, large organic compounds must first be broken down into their smaller constituent parts. Secondly, the biological process of acidogenesis results in breakdown of the remaining components by acidogenic bacteria. The third stage of anaerobic digestion is acidogenesis. Here, simple molecules created through the acidogenesis phase are digested by acetogens. The third stage of anaerobic digestion is the biological process of methanogenesis. Here, methanogenesis uses the intermediate products of the preceding stages and convert them into methane, carbon dioxide, and water. Methanogens are bacteria that produce methane as a metabolic byproduct. When treating wastewater through the anaerobic digestion process, in order to allow the functioning bacteria such as methanogens to grow, environmental factors including temperature, pH, oxygen, nutrients, etc. must be carefully controlled. Here, I would like to introduce an innovative invention called information biobooster. The operating parameters can be modified at any time to meet the influence of water quality change on the optimal conditions for microbial cultivation. Environment and anaerobic condition. The operating parameters can be modified at any time to meet the influence of water quality changes on the optimal conditions for microbial cultivation. It can be connected to any wastewater treatment unit to improve its performance. The basic principles of the IBB system is that the control tank is optimized by bio-automation, customer-designed software, and the central operating system. The efficiency of the living cells converting energy is improved, and therefore, the cost for treating wastewater is reduced and high-quality treated water is produced. Improvements of biogas production using IBB system was conducted at the biochemical plant in Lianyungang. The plant's main business is the production of alcohol and other products through cassava fermentation. The annual production of cassava distiller wastewater is more than 3 million tons. The plant's number 19 IC anaerobic reactor were connected to 2 IBB reactors. The installation of IBB systems follows the following process order. In steps 1 to 3, labor experiments are conducted to gain background information of bacterial community and nutrient connections. Steps 4 to 5 include importing labor results into control system, automatically controlling plant operation. IBB system is an intelligent system which adopts IoT technology with the capability of real-time monitoring of operating conditions. And safe analysis function is also economically efficient and environmentally friendly. This is just one of the choices for professionals to save water by turning wastewater to resources. Yet, every one of you can also participate in water protection. Here are 6 steps that you can follow to help save our precious water resources. Develop the habit of protecting water resources and eliminate wasteful behavior. Establish environmental awareness and take the initiative to learn the skills of caring for water resources. Adhere to the priority of water saving. Cherish the existing water resources and cherish the existing water resources. Adhere to recycling water to improve the utilization rate of water resources. Spread knowledge about water conservation to people around. Adhere to green way of life and green development. Together, we are able to create a better world. That would be all for today's lesson. I sincerely hope you can understand. Wastewater is a resource. Energy can be from wastewater. Thank you.